Hello, everyone. Good afternoon, and thank you for coming. And thank you to those who attended our session yesterday, highlighting examples and pilot projects. My name is Jennifer Barrett. I'm the Managing Director at the Canadian Urban Institute, and we're excited to be hosting this session as part of the Design Innovation for Middle Housing Single Stair Sessions series with our colleagues at LGA Architectural Partners. Today's session is part two in the three-part series, and we'll focus specifically on safety and sustainability with presentations from professionals across North America, including those from Sweden, the UK, the US, and Canada. Day three, tomorrow, will be a CUI City Talk that will focus more broadly on the topic of housing innovation, how policy constraints impact where and how we build housing, and how regulations can either stifle or encourage innovation. I'd like to note that this knowledge mobilization event is supported by the Canada Mortgage and Housing Corporation as part of their Housing Supply Challenge Round 4 Building for the Future and funded by the Government of Canada. I would also like to acknowledge that all of us on the call are coming today from hundreds of communities across Canada and abroad. Here at the Canadian Urban Institute, we acknowledge the diversity of Indigenous people, including First Nations, Inuit, and Métis, who steward the places we call home, and reiterate our individual and collective responsibility to foster understanding, respect, and appreciation for the traditional keepers of this land. I'm joining you today from Ottawa, Ontario, the unceded territory of the Algonquin and Anishinaabe people, and many of our staff work from our head office at CUI in Toronto, the home of Indigenous peoples covered by Treaty 13, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. We honor their enduring connection to keeping this land and commit to an ongoing process of truth and reconciliation. I would now like to turn it over to Conrad Spechtert from LGA Architectural Partners to give a recap of yesterday's session, which will be followed by presentations from our professionals. Thank you.
Thanks, Jennifer. So LJ is really excited to be here today. We've been working on this project for the last year and a half as part of the CMHC Housing Supply Challenge. Yesterday was a focus on architectural aspects. Today's focus will be on safety and sustainability of single-stair building design. And so today we're going to hear from architects, fire engineers, and building code experts from Sweden, Canada, the United Kingdom, and the US. Axel Mosberg will talk a little bit about Sweden's building code requirements for single-stair design. Carl Wallish is joining us from the UK to discuss regulatory reform following the Grenfell Tower disaster and subsequent code change there. Mike Mariano is an architect in Seattle. He will walk us through the Capitol Hill Urban Co-housing project, where he lives and works in a 5-story single-stair building. We'll then turn to the Canadian context and hear from GHL consultants who have been working on a very detailed technical report on SES building design recommendations. We'll hear from Ian Mulder at the City of Edmonton, who will present the point access block guide that the city have developed. And lastly, we'll hear from Ryan Brewer of Half Climate Design, which will touch on some key considerations in terms of embodied carbon and construction type for exit stairs. But just to quickly recap for anyone who wasn't around yesterday, you heard from LGA and 3 other architects as we presented pilot projects and prototypes for single-stair housing across Canada. We looked at the cost benefit of single-stair design with 6 prototypes for infill housing. This was in terms of floor area efficiency, construction cost, net operating income, and residual land value. And so there's been a lot of changes recently to zoning regulations and planning policy across Canada to allow for more housing in existing neighborhoods, really as an alternative to suburban sprawl. However, this type of what we might call gentle density, buildings like multiplexes of up to 4 units or small apartment buildings of up to 6 stories, are challenging to build on small lots. And so the goal of single-stair design is really threefold. Firstly, it is to make these missing middle and small mid-rise housing types easier to build. 2, it makes to make the development of smaller sites more viable. And that really leads to 3, which is to enable small scale, what we might call citizen developers, types of organizations without the large amounts of capital required for land assembly or to acquire larger properties. Just to quickly talk about the prescriptive code, the National Building Code under Section 3421 and 998 says that any floor area in a building of not more than 2 stories in height is permitted to be served by one exit, with a total occupant load served of not more than 60. And so in other words, any multi-unit residential building, except for a stacked townhouse, of more than 2 stories is required to have 2 separate exits. This diagram shows the maximum height for single-stair multi-unit residential buildings in jurisdictions around the world. As we work our way down the drawing, you'll see a clustering of countries around the 6 to 8 story height range, which really corresponds to the height at which additional high-rise measures are required in the Canadian context. LGA and David Hein Engineering submitted 2 code change requests to the National Building Code to allow single egress for buildings of up to 3 and 6 stories in height. And it is our understanding that this is at least a priority topic for the 2025 to 2030 code cycle. Since the first edition of the National Building Code of Canada was written in 1941, the NBC has contained the prescriptive model code requirements for the design of buildings in Canada. And in 2005, the NBC was transitioned to what we call an objective-based code, which introduced the objectives and functional statements to really clarify what the goals are of the NBC's prescriptive requirements and what they are intended to achieve. And so this is one option of code compliance, since acceptable solutions by default meet the intended objectives of the code. The other option is the use of alternative solutions, which must achieve at least the same level of performance related to the objectives assigned to the associated provisions. I'll just note as well that single stair in Canada is not a new idea. In 1984, 2 architects wrote a research report for CMHC to document the differences in apartment building layout in terms of fire safety. In the 1990s, a very well-known architect wrote 2 papers on the challenge in building Main Street's housing, particularly in terms of the 2 exit stair requirement and parking requirements. And then in 1996, the former assistant director of the Ontario Building Code had written a study proposing single stair changes to the Ontario Building Code. And so today, 40 years later, this technical issue is receiving a lot more attention given recent planning policy reforms. The United States revised their limit on single stair about 20 years ago in recognition particularly of sprinkler system performance and reliability. And so it is in many ways long overdue to discuss alternative solutions to address this issue in Canada. Last year, the NFPA, the National Fire Protection Association, also held a symposium to discuss single exit stair and to hear from stakeholders, particularly in fire services across North America. The report included a comparison of fire statistics between building types. And according to the NFPA data, single detached houses are statistically the most dangerous type of housing, with a death rate of 25 persons per million. On the other hand, apartment buildings of 3 to 6 stories have a death rate that is 80% lower. And so I mention this because many parts of the building code make it very easy to build houses, while adding many costs and complexities to the construction of small apartment buildings. And now, as Canadian cities look to change land use policies and zoning bylaws, we will inherently increase the fire safety of Canadians by providing more housing options that are in sprinklered and fire alarm buildings. We will also be decreasing our per capita carbon emissions by eliminating further suburban sprawl and urban boundary expansion. And so with that, I'm going to turn it over to Axel Mosberg to talk a bit about a Swedish perspective.
Right, let's see if I can share my screen. Let's go. There we go. There we go. Hello, everyone. I'm Axel Mosberg, and I'm very happy to be here and to talk about the Swedish perspective on single exit stair solutions. Let's see, I think you got my bio in the chat, but I am a fire safety consultant in Sweden, I'm also the research director of Sweden's largest fire safety consultant company. And I have a small research unit with 3 people currently, where we do both research and design work. I did my PhD in elevator evacuation and evacuation of high-rise buildings, and also other complex environments such as underground stations and so on. I've also been the project lead for the Swedish SFP best practice guidance for how to do performance-based design in complex buildings, where high-rise buildings is one of those situations that we have in Sweden. And also I do some standardization work. But I'm here to talk about the Swedish building regulation and what we do in Sweden in terms of single exit solutions. And to just give a sort of framework is that we have a performance-based building code in Sweden. So we have functional requirements, which are, well, they describe the function, at least ideally, what the building should perform, and they are not allowed to be deviated from. You always have to fulfill the functional requirement. However, then you have a general recommendation, which is similar to a deemed to safety solution. Pretty much, it's a recommendation on how to fulfill the functional requirement, but you are allowed to deviate from it as long as you fulfill at least the same safety level or the safety level of the performance-based code that we have. We also, something that might be good to know is that we have no general recommendation for buildings above 16th floor. So that's once you get above 16th floors, you have to do performance-based design, which is why the Swedish arrow in Conrad's picture was on 16 floors. That does not mean that you can't build single stair solutions higher than 16 floor. It's just that it's not included in the building code. You have to do a performance-based design, but there are a lot of buildings with more than 16 floors, which I'm going to show you in a bit here. Also, in general, it's good to know that Swedish buildings are not very sprinklered. We have sprinklers in Sweden too, of course, but in general, especially for housing, it is not a very common solution to sprinkler, and it's not included in the code. It's just if you do a performance-based design that you would include sprinklers in housing. It's required in hospitals and elderly housing, but it's also a common system to put in as a performance-based measure, pretty much. And single exit stairs solutions are allowed for housing or apartment buildings, and also for office use. It's not allowed for public use, but for this that I mentioned. So I'm just gonna flip through a sort of standard cases here in Sweden. This is a 2 to 3 story building. Here we have you're allowed to have one exit, and it doesn't have to be fire compartmentized. This is just a regular house, pretty much, or houses built together, and you're allowed to jump from your window up to 5 meters above the ground. So it's a self-evacuation strategy, pretty much. So the rescue service are not intended to be part of the evacuation strategy here. And for buildings that have a few more stories, up to maximum 8 stories, and also with windows that are below 23 meters above the ground, you can use ladder rescue as your alternative exit. So then you're allowed to have a open stair, which is a stair you can see here on the picture, a open stair without smoke vestibules or fire compartments in between. So you just have your apartment door, which doesn't have to have a closer or anything. It's just a regular door, and this can be open in up to 8 stories. The load-bearing system here is R60, which is a standard requirement in Sweden for these type of buildings, and the doors are required to be smoke tight as they open up to the stair. So it's the S200 means that that's a smoke tightness requirement, pretty much. So that is up to 8 stories or 23 meters above ground. If you go above that, if you have a building with up to 16 stories, which is this is also an apartment building, you are allowed to have a single exit stairs if you do it as a TR2 stair, as we call it in Sweden, or TR2 trappa in Swedish. Then the difference between a regular stair and a TR2 stair is that you have a smoke vestibule in between. So here is a fire compartment between the apartments and the stair. So if there's a fire in one apartment and the door is open, you will only affect the apartment on that specific floor. The stair will still be protected. It will have a smoke lobby. Here we have a higher requirement on the load-bearing capacity. We still have the smoke tightness on the doors towards the stair, but you have a lower smoke tightness requirement for the apartment doors, which is the difference in these ones. Also, the door heading to the stair here has to have a closer, but the other door does not have to have a closer on them, pretty much. For buildings above 16 stories, as I mentioned, we do not have a general recommendation or it's performance-based design, but based on experience, I can tell you that we have a lot of 16 plus story buildings, apartment buildings with one single exit stairs. You then have to have a TR1 stair or T1-trappa, as we say in Swedish. The TR1 stair is pretty much a smoke lobby with a pressurization system of the stairwell. So you pressurize the stair and remove the exhaust air pretty much, often using the elevator shaft. You have to use performance-based design, as I mentioned. Just talking from experience here, so this will be different for each project, but for up to around 20 to 22 floors, it's very common to do this without sprinklers. And the performance-based design will then compare the different stair solutions pretty much. And when you go above about 22 floors, you generally put in sprinklers to make the risk analysis come together pretty much. It's the same load bearing requirement. You still have the smoke tightness requirement on the doors to the stair. It has to be a closer to the stair. It's also closers on the doors towards the smoke lobby. In this case, but there's no closer on the doors towards the separate smoke vestibules here. You can also put apartments heading just directly into the first smoke vestibule here, but then you would have a closer requirement, and due to the Swedish availability or requirement, that is a very uncommon solution. So usually you put a separate smoke vestibule just to get around the closer requirement. So you would, due to availability requirements. Also, I thought I'd give you a few examples. I've mostly been talking about apartment buildings, and we have our Sweden's second largest or tallest building is an apartment building called Turning Torso. It was built in 2005. And it was just passed by Karlatornet here in Gothenburg last year in tallness. And it's 52 stories, 190 meters high. It's a residential building. It has sprinklers and stuff. It's a PVD fire safety design. But it's also a single stair building, yeah. And then I give you, this is another example on the right. It's Kista Science Tower. That is a office building in Sweden. Which is 32 stories and 124 meters high. It is an office building, also a single stair building, also performed with performance-based design. But it's similar to, just to give an example on office buildings as well. I currently have a few projects, which is ranging from 20 to 27 floors with mix different, some residential projects and some office projects with this single exit stairs solutions buildings. So, and also just a finishing note here is that the Swedish requirements for fire compartmentation is in general EI60. It's a 60 minutes standard fire resistance. Also, it should be noted that the facade requirement is that they should be non-combustible, at least for buildings with 3 or more floors. or pass a national test, which is called SP Fire 105, which is a full-scale fire test. As you can see a picture of it here. You build pretty much 3 stories of your facade, and then you can't have a fire spread above the second window, pretty much, or below the second window. Generally, it should be noted also that we have a quite high level of quality in buildings, I would say, just looking when I've been around internationally, especially when we're talking about tightness of buildings. In Sweden, it's a cold country. I guess Canada is the same, but we are quite good at tightness in our building, pretty much. So that was my short slides on the Swedish building code. If you have any questions, you put them in or contact me. These are my contacts. And now I'll leave the word to Carl. There we go.
Great. Thank you and welcome, everyone. I'm just sharing my slides. I hope you can see this all now. It's a pleasure to be here. Thank you. Good morning, good afternoon, good evening. My name is Karl Balasch. I'm German, as you might hear from my accent, but I'm a fire safety engineer and I've been working in the UK for nearly 20 years. So it's my pleasure today to give you a single stair perspective for residential buildings from the UK. And it was really interesting to hear from the previous presentations. You will probably see some similarities, but also some differences. So similar to Axel, I will start with the UK legislation. What do you need to consider if you design and build something in the UK? Well, we've got 2 pieces of legislation. One is the one we have to consider when we design and construct a building, which is the building regulations. And then we have another piece of legislation that comes into play when the building is in use and occupied, obviously a much longer phase of the building. Today, we'll only focus on design and construction stage, the building regulations. And when you're a fire safety engineer, similar to other countries, there are a few areas you need to consider, and the building regulations are telling us to focus on. Focus is in generally life safety, and we do have to consider the means of escape. How do we get people out, but also how do we get fire brigade safely in? Then we need to consider the materials to prevent internal fire spread, structural resistance, but also external fire spread and access and facilities for the fire service. And what's now so special about these building regulations? Well, similar to Sweden, they are functional in nature. So what does this mean? The building regulations won't tell any designer how many stairs a building needs, or how many exits, or how wide stairs need to be, etc. But they give us a functional performance that is expected the building will achieve. And because we're talking about single stairs today, I brought you just a text from a means of escape. So as a designer, you have to design and construct this building with appropriate provision to achieve an appropriate means of escape, allowing people to leave the building to a place of safety. Appropriate. Wow. What does this mean? Can you imagine I would tell an architect, just design it appropriately. You don't need me. Well, that's not really helpful. Our regulator knows this. So whilst we have to comply with the building regulations, there's no nice to comply with them or not. No, you must comply with them. You must comply with the functional requirements. The regulator has given us different compliance routes, different guidance documents that we can apply, deemed to satisfied, I think, were the words that Axel used. And the most standard route to achieve compliance with the building regulations is considered to be the approved document B. B, because it deals with fire safety. There are other approved documents that deal with other things designers have to consider. Today, we just focus on approved document B. And it's a standard document. We'll talk about this in a bit more detail. When I started in 2006 for single stair residential, well, there was no limit. It was just giving us guidance how to design a single stair building, but it was not restricting the height. And there's a second route, which we call risk-based approach. So this is using British standards, and this is using a different way how to get to an answer. For example, if you want to establish the maximum travel distance in a building, this document would ask you questions about the users of the building. Who is there? Are they awake? Are they familiar? Are they sleeping? But it would also ask you things about the building. What's the geometry? What's my ceiling height? But then also, what is the active and fire safety provisions you anticipate to be in the building? Detection, yes, okay, detection allows you to increase the travel distance. Sprinklers, yes, because sprinklers allow you then also to increase the travel distance. So it's a package, it's a measurement, a risk-based approach that you can choose to come to your answer. And again, in this document, in particular BS 9991, we'll have a look in a second. Up till autumn last year, there was no height restrictions for single-stair residential buildings. It was giving us guidance how to design single-stair residential buildings, but not restricting the height of those. And here in the UK, we're really proud of this. We have a third route of approval. And Axel mentioned this again, it's performance-based design, purely application of fire engineering. We've got an entire British standard about this, how to apply safely fire or performance-based design for buildings. So it's really important to understand that in the UK, you must comply with the building regulations, but you've got different routes that you can choose. And now let's look a bit in more detail about these different routes. I mentioned to you already that approved document B was the standard guidance and didn't, when I came to the UK, didn't restrict the height of the building. Obviously, we had in June 2017 the Grenfell tragedy, and a single-stair residential building, 24 stories, not sprinklered, had a fire, and unfortunately, over 70 people died. A shock, a really shock, not just to fire engineers, but to everyone in our society. And the question was brought up on the way in the years after, how do we actually deal with single-stair buildings? Why do we have them? And the few things that I just want to highlight in this timeline is that suddenly the residential sprinklers were introduced from 30 meters height to 11 meters height. So they brought down the recommendation for sprinklers for block of flats. And there was the National Fire Chief Council and Association that brings the fire brigades together in December 2022. And they said, well, we believe here, it's our opinion that we should restrict residential buildings with a height of up to 18 meters or beyond 18 meters. And in the same month, our government released a consultation asking the industry, should we consider a restriction of height for single-stair buildings in residential design? Should this be 30 meters, question mark. In London was quicker. London suddenly said a few months later, you can no longer build tall towers with a single stair over 30 meters. And the industry was really confused. Finally, the government in 2023 and up to 2024 confirmed that it's their wish to change the guidance, not the building regulations. They remain functional, but the guidance of approved document B. And instead of 30 meters, they recommended now a height restriction of 18 meters. This document is released, but it's not in place yet. It will come into effect in September 2026. So where does this leave us in the industry? I mentioned to you already approved document B. Currently, we could still design single-stair buildings without any height restriction because it just comes into effect in about a year's time. And we do have built already single-stair residential block of flats, not just over 50 or 100 meters. We have them over 200 meters. I think one of the tallest is 240 meters. But of course, we know ADB is changing. The appetite of this is changing, and no one, as I'm aware, is building single-stair buildings at the moment. And what will they look in the future? Single-stair residential buildings will be up to 18 meters height. You can see in these diagrams, they restrict travel distance to 7.5 meters in a single direction. They expect the stair to be ventilated, the lobby in front of the stair to be ventilated, general compartmentation of 60 minutes between flats, and they expect sprinklers throughout if you're over 11 meters. And they are based on a stay put policy, which means only those in the flat where the fire occurs will ask to evacuate. That's ADB. It's changing. Now let's look at the second route, the risk-based approach, BS 9991, because there was a version from 2015, and suddenly in November 2024 it was updated, and suddenly everybody was surprised, or not, but it did restrict with immediate effect pretty much from the end of November 2024 the use of single stair buildings and residential use over 18 meters. So there's the recommendation to have 2 stairs now for taller buildings, but up to 18 meters, you can still build with a single stair. And similar to the thinking in ADB, we're looking at travel distance and dead ends of 7.5 meters. If you have sprinklers, you can double this up to 15, so a bit more flexibility. It looks at ventilation of the corridors. It looks at ventilation to the lobby in front of the stair. It's based on sprinklers, stay put. It also talks much more in detail about evacuation lifts, because it's a huge discussion in the UK how we evacuate mobility impaired person. So you can see already slight difference in ADB and 9991, but we know the direction that is going. We now have, or will have, a height restrictions in both these routes. And I just emphasize a bit on smoke ventilation, because we think in 3 different ventilation systems. The stair needs a ventilation, often a vent on top that just opens and provides a way of natural air in. Then the lobby in front of the stair needs pretty much the same ventilation as the stair, a natural shaft. And then the corridors, which have direct access to the flat, and the corridors where we expect smoke in the first instance, spreading from the flat into the corridor, should either have natural ventilation. For taller buildings, we expect it should be mechanical, or a pressurization system that we also have seen working, or in the Swedish slides, where you create a positive pressure to prevent smoke spread into certain areas. And a key area of these single stair buildings will be, or has always been, the ground floor. How do we get people really out from the stair, ideally directly to the outside, without letting them pass again through corridors or flats or other risk areas? So we come to the summary. Here in the UK, we have 12,500 buildings, residential buildings that we call higher risk because they're over 18 meters. They are built since the 60s. We have them. And we do know quite a lot of them have a single stair. And we do know that some are over 200 meters. But obviously, since Grenfell, really this topic has been widely discussed in our industry and has brought attention from all kinds of stakeholders. And people have started to wanting, in a way, or responding to this public perception to restrict the single stair with a height. And people were thinking about 30 meters, 18 meters. Some people said 10 stories. For a longer period, we had uncertainty in a way that's now overcome. We do have this height restriction of 18 meters, but ladies and gentlemen, I can't even tell you why it's 18 meters. There's no scientific evidence or research supporting the 18 meters. And I doubt we will ever get this. We have just used 18 meters because it's somewhere in our height system in the UK. And it's interesting, as a fire safety engineer, just maybe my last point is that this height restriction, and it was discussed, you know, everyone had really an opinion about this, but it came down to a political decision, and really driven, interestingly, by insurers or funders, because a lot of them had the thinking that they do not wish to build and invest for 50, 60 plus years in a building that might be seen as unsafe. So they were actually the first ones to introduce certain height criteria. And that's it from the UK. I do thank you, and I'll pass on to the next presenter.
Hi, everyone. I'm Mike Mariano at Schemata Workshop. I'm architect and developer and a resident of a project that we call Capitol Hill Urban Co-Housing. Based in Seattle, we have a small practice on the ground floor of the same building. Architecture studio of 16 people, do a wide variety of work, including housing, a lot of affordable housing for nonprofit housing developers, category we call infrastructure related to transportation, mobility, and other opportunities for us. A brief history of the single egress stair in Seattle. In 1977, a building of any height, with not more than 4 units per floor, could actually have a single means of egress in the building, a single stair. That was 77. 85, it was reduced from any height to 6 floors in height, no more than 4 dwelling units per floor. And current code allows up to 5 stories of residential R2 occupancy, no more than 4 dwelling units per floor. We had some state legislation that came before our local agency last week and was passed and will be enforced at the state level, or available to everyone at the state level as of July 2026. Our office has done a few single means of egress stairs, including this one, Sola, which has 8 homes. The image on the right, the floor plan, shows the single stair, the elevator opening onto it. This is for a developer that really wanted, a high efficiency factor for each of the floor plans. So there's no community area associated with that. It meets the intent of the code really at a bare minimum. There are other examples of single egress stair buildings in Seattle. Spent some time on the land use application of the one in the middle, which is a type 3, non-combustible material building. All 3 of these have very compact vertical circulation in them. So stairs and elevators that are really super efficient, which was interesting, but I also found that there was tremendous opportunity to capture that and make it more of a common area. So what I'm going to talk about for the remainder of my few minutes is a project we call Capitol Hill Urban Co-housing. So approximately located where the red circle is on this image, you can see the Seattle skyline in the distance. We're walking distance to the city center. The Capitol Hill neighborhood was in the news internationally a few years ago for the Capitol Hill Occupied Protest Zone, which is essentially just to the left of the red circle. So this ground zero for protests occurring in the East Precinct, which is just on the left of the image here. We have light rail station just to the right of the park on the image as well. An aerial view of our project. So this is essentially a 5-story building. We are similar to the one on the left. So I actually have to say that we're the yellow and light gray one on the right. So the one on the left was built a couple years prior to ours under the exact same zoning restrictions for height, setbacks off the power lines, similar really tight construction budget, tight construction cost budget that we're trying to hit. So they ended up looking kind of similar, but there's actually 32 units in the building on the left, 4 stair towers, no elevator, and 4 units, up to 4 units per floor. Our building, the one on the right, is 9 homes surrounding a courtyard space and a single egress stair and elevator. That single egress stair and elevator is in the image on the left here. So you can see some of the safety measures that are visible here, but we do have a full NFPA 13 sprinkler system throughout the building, fire alarm system, smoke detection. You can see the damper at the top of the elevator hoistway. We actually saved some money by not taking the elevator all the way up to this upper roof level, but there is a smoke and fire damper for a naturally ventilated elevator hoistway there. There is a stair pressurization fan just on the upper right here that you can see that actually pressurizes the stairs. So each of those egress balconies provides access to anywhere from 1 to 3 units per floor, no greater than a 6-meter distance from the front door to that doorway. Beyond the building, so the single egress stair in our case allowed us to do an economical building that we could get 9 families together and develop on our own. So this idea of co-housing is something that originated in Denmark and was brought to the US somewhat recently, a few decades ago. But this idea of kind of living in a community, intentionally knowing your neighbors. We actually got this group together before we had a building. There's a deep focus on community and and privacy, the ability to kind of live together but have your own home, so you can walk out your door and find a community and activity, but being able to retreat, to your home as you would anywhere else. I call it a very comprehensive approach to resilience, the idea of knowing your neighbors and that those are the most resilient communities that we can build. A section through the building. So our primary street is on the left here, 12th Avenue. There's an alley on the right. The site actually sloped about a story up to the right. So we carved this courtyard out of the building, that stairwell, single egress stair, and the elevators directly off of that. We've got 2 units per floor on the left for a total of 6. We've got what we call the common house, so large community room, with the highest occupant load directly off the alley, which allows egress out to that. The courtyard, there's 3 units stacked above here. My home is actually the one right in the middle here with the balcony. We have our architecture studio for schematic workshop, an office of 16 people down in the ground level. That single egress stair and the elevator and those balconies open to a very compact courtyard space that's about 5.5 meters by 6 meters in distance. The balconies add a little more space to that, but it's essentially what we call kind of the heart and soul of the community. So all the homes are whatever you can think of might be a home, but it's that common area, that circulation space, in the diagram in the middle, we've drawn in yellow. So it's that common area that connects us all together socially. So activities that take place around that courtyard space and that single egress stair. Typical floor plan here, 2 units on the left. In yellow is the elevator and the stair and that egress balcony. Again, no more than 6 meters of distance from one of the unit entry doors to the stairwell door. Doors are rated, on closers. The stair is pressurized. The balcony is open. We used a planning approach that we came across in Denmark too, that essentially created kind of semi-public areas of the home at that front door and kind of going deeper into the building for more private areas. An example of one of those homes, looking east away from that courtyard space and out to the private balcony in the home, looking the other direction towards that courtyard space. For those who have seen TED Talk that my partner gave on living in community, this is one of the still images from that. Spencer is actually in his window, about a 6 meter distance, from where I stand. The image on the right shows our front door and those egress balconies, the elevator, and the stairs are right over there as well. One of the advantages of that open space, I can open my front door and periodically come across activity occurring out in that space. So, rather than a double loaded corridor and multiple stairs, serving a, distributed kind of social function throughout the building, we've concentrated all of this activity into a fairly, dense little space, that allows access to that stair and the elevator and overlooking that courtyard space. The courtyard is in the foreground. The elevator is off to the right here. Those egress balconies you can see. We've got a rooftop farm up there that looks out to the west. The occupant load up here, was designed to be about 10. So, the beds actually consume a fair amount of that space specifically to keep the occupant load down. I'm looking down into that courtyard, throughout the year, there's a tremendous amount of activity that takes place. So again, that concentration that's allowed by having that single egress stair and the concentration of activity in the community. My partner and I are constantly taking photos down because it's just kind of this interesting reminder of the liveliness of community and living intentionally there. Something that came up yesterday in a lot of conversation was the ability to provide, bike maintenance rooms in the building. The middle image here on the top is me kind of rationalizing the investment that I've made in a lot of bicycle tools and maintenance equipment and offering a 2 times a year bike tune-up day for the community. Again, kind of, this multi-purpose space kind of at the heart and soul of the community, serving a variety of functions, celebrations, watching the weather kind of between and outside the homes. So that's, an overview of kind of looking at, what a compact building, developed intentionally for community can look like. It's just one example. We had a tight construction budget. There were a lot of constraints that we were dealing with, but we're excited about the outcome. Thank you again to Conrad and everyone that put on this conversation today, and I'm looking forward to questions. I'm going to hand it off to Morgan next.
Hello, everyone. Just getting everything shared here. All right. So my firm here, GHL Consultants, we wrote a report on single exit stair building design in the Canadian context. I'm going to run through the high-level overview of it. Let me just get that out of the way here. Okay, so GHL, who are we? We're a firm of engineers, architects, and technologists founded in 1992. We're based out of Vancouver, BC. So we're a building code consulting firm, first and foremost. So we help engineers, architects, and developers in interpreting and applying the building code. That includes alternative solutions. So if you haven't actually heard of us, you probably felt our effects throughout the Canadian building industry. We were an advisory consultant on the 6-story wood frame code change, and Tallwood House at UBC is one of our major milestone projects, the 18-story mass timber building. So our report was written for round 4 of the CMHC Housing Supply Challenge. In it, we provide recommendations for residential buildings up to 6 stories in building height that are served by a single exit stair. And we make recommendations in both Part 3 and Part 9 of the code. We go a lot more in depth into Part 3 than Part 9. So this report is a public document. I believe it has been published now. And the intention is that this report is used as a resource for professionals to develop alternative solutions for single exit stair buildings in Canada. Apologies. So the background for this report was developed in response to the rising discussion around the topic of single exit stair buildings in Canada. We saw a lot of these early conversations around code changes, especially in BC. We definitely felt a lot of it happening very quickly, and thought that we could add some valuable discussion to the topic as a whole. The report is based entirely in the National Building Code 2020 edition. We prepared it completely independently of the BC 2024 code change. We did that just so we could completely take it as a separate sort of endeavor. We ended up coming to many of the same conclusions, although there were some provisions that we ended up disagreeing on in the BC 2024 code change. So the report is generally structured in this way. So we have to define the problem. Then we take a jurisdictional scan of SES building design from different building codes around the world. We do an egress analysis of prototype SES buildings. Those prototype buildings were created by LGA. We do a retrospective analysis of the NBC to give some sort of context between an older version of the National Building Code and the modern version of the National Building Code in order to show how much better buildings are now compared to when they were in 1980. Sprinkler reliability and fire data, we'd have a short discussion on that. And then we add some discussion around smoke protection measures of a single exit stair. So with the National Building Code, first thing you have to do with anything in the building code, you have to read what it says. So what this whole thing is based around is sentence 3421, which prescribes 2 exit stairs. But it says sentences 2 to 4 are when you're allowed to have a single exit stair condition. in Canada. So sentences 2 to 4 are very important for when you're writing any sort of alternative solution to this, because they will shape the discussion around the thought process of the NBC when it permits the inclusion of a single exit stair condition within a building. So what it does, you have to consider the level of risk in the acceptable solutions and what how they're mitigated and what is considered to be acceptable for when the building code allows you to have a single exit stair condition. And those answers lie within the intent statements of sentences 2 to 4, which says limit the floor area, limit the occupant load, limit the travel distance, make sure that when you're discharging, you're not discharging, 1 story up of the building, and that there's occupant familiarity. So with the building code, it says either you meet the acceptable solution or you can produce an alternative solution. An alternative solution is a solution that meets the minimum level of performance required by Division B in areas defined by the objective and functional statements of the code. So the intent statements are there. They're not required to be satisfied, but they help color discussion. So we thought it would be very important to talk about the intent statements, and we talk about them in the report. The objective and functional statements for sentence 34211, which is the sentence that you would be writing any alternative solution to, has 4 functional statements tied to 3 objective statements. I'm not going to go through all of them, but to bring it back, it's about the objective and functional statements attributed to the applicable, acceptable solutions. So that just brings it all the way around to our opinion is that you can take the performance of a single exit stair building with additional measures and compare that to a 2 exit stair building under Division B, and it would perform as well as that building. Next part of the report, we go into a discussion on risk and risk analyses. We're recommending, if you're doing an alternative solution, that some sort of risk analysis is provided just to help quantify the level of performance of the solution that you're proposing. Quality of data is really key. So acquiring that is I think paramount to any discussion around that. There are 2 guides in NFPA, 550 and 551, that could be helpful for this. We identified those 2. It's not the only way to do it, but give options here. 551 is likely the direction that I'll be taking whenever I produce an alternative solution for this. It's tough because it's hard to do a fully quantitative analysis. You need a lot of data to do so. So you can do a semi-quantitative analysis based on likelihood or consequence, and it allows you to control for variables, and it allows you to make a reasonable judgment at the end of it. Next in the report, we go through a jurisdictional scan across different building codes that permit the single exit stair condition in residential buildings. So there's a lot around the world that do that, but we shortlisted it to 7 different building codes: Seattle, New York City, England and Wales, Sweden, Finland, Australia, and New Zealand. So we took those building codes, analyzed them, broke the provisions down into 4 overarching categories for general building provisions: egress, exiting, fire separations, and fire department provisions. From there, we break it more down into, what construction type can you do? What's the maximum building area? What's the maximum building height that you can do in a single exit stair building? Do you require sprinklers, fire alarm, all that stuff? And then from there, we take what we know in these other codes, and then try and translate that to a Canadian context, put that squarely within the building code that we use, and from there, try and make a reasonable assumption as to how can we, as well as we can, address the objective and functional statements related to the single or the two exit stair requirement. So, bringing it back around, like I was saying, we're looking for what we have to do is try and limit the occupant load, limit the maximum floor area, limit the maximum travel distance, make sure that the exterior discharge is basically at ground level, and occupant familiarity. So for something like occupant load, when we did an analysis, we would take the Division B solution of a 6-story wood frame building with 2 exits. There's no limit to the amount of dwelling units that you can have on there. You're limited by the exit capacity of the 2 stairs, and it's generally about 275 people. So that means you have 1,375 potential cumulative occupant load, all the way down to level 1, where it discharges out. Our suggested limits for single exit stair buildings is maximum 6 dwelling units per story, an occupant load of 30 persons, and that would mean it's a 150-person cumulative occupant load on the 5 upper stories, and maximum of 20 dwelling units served by the single exit stair.
Hi, Morgan. Just gonna ask if you can move really quickly through the rest of our slides because we have 2 more presentations to get through. So what we can also do is have a follow-up session to go in this in more detail. So really just 1 sentence for each one, and then we can get time for the last 2 presentations.
Yeah, you bet. Okay, so we do the same thing for travel distance. We do a comparison between the Division B scenario and make a recommendation for the single exit stair building design. In the end, at the end of that section, we collate everything into general recommendations all the way through of each overarching section and each subsection. We do a Part 9 analysis where we do a comparative analysis between Division B and the SES building. It's based on the Part 3 analysis. It's nowhere near as in-depth, but essentially you're sprinklering the building and it makes it that much safer. So we go through an egress analysis using Conrad's or LGA's prototype design buildings. We do use the SFPE guide for human behavior and fire. The analysis, essentially, it's as you would think it would be. You have less people, less density. Less density means quicker egress time. We go through a retrospective analysis of the BCBC or the NBC provisions. We set it at NBC 1980 versus the modern NBC and compare the level of performance. Again, we're expecting that, or we found that, modern NBC would outperform the NBC 1980. So we think this is important because there are design innovations that became acceptable solutions, but were initially based on an alternative solution approach, which is one of these things. One of these things are the introduction of the 6-story wood frame building that used to be an alternative solution. Now it's code. We go through a sprinkler reliability analysis, and we use the NFPA report, U.S. experience with sprinklers. It's fire data. Long and short of it is sprinklers and fire alarms in your building, and your death rate goes way down. Same thing with the BC Office of the Fire Commissioner annual report. Sprinkler your building, fire alarm, deaths go way down. There are limits with fire data, and we talk about that. It's related to outcomes. The outcome is only injury or death, and there's no discussion on if fire prevented the occupants from leaving. Doesn't stratify by year of construction, the standard of sprinkler. So we talk quickly in the report about smoke control in the single exit stair context. We don't prescribe smoke control in non-high-rise buildings, just because we expect the evacuation time to be low enough that smoke development will not affect that. However, we do think that some sort of smoke protection of a single exit stair should be provided, and we came up with 4 potential means: exterior passageway, which accesses the stair, a vestibule between the single exit stair and the public corridor, the smoke exhaust or extraction method, or just pressurizing the single exit stair. So as a quick check, our opinion is that a 6-story sprinklered single exit building is much safer from a fire and life safety perspective than a 3-story unsprinklered building with a public corridor and 2 exits that's permitted to be designed through Division B, or a 600 square meter 3-story unsprinklered house, also going to be designed and constructed through Division B. So our conclusion at the end of the report is we believe that the performance of 1 exit stair plus some enhancements can perform as well as the performance of 2 exit stairs plus the regular Division B provisions. And we do that through limiting occupant load, limiting maximum floor area, limiting maximum travel distance, exit discharging to grade, and the dwelling units have an inherent level of assumed occupant familiarity with the building. Other things that we would do to enhance: NFPA 13 sprinkler standard regardless of building height, smoke detectors in lieu of smoke alarms in dwelling units. That's a direct code compliant provision, but it allows it to be fire alarm devices, so you can see them on the panel. No 20-minute doors, so you have to have 45-minute FPR doors, requiring 2-layer construction at combustible floor assemblies and at the exit fire separations. Increase of the stair landing width to 1,500 millimeters for counterflow. So if there are responding firefighters at the same time as people are evacuating, there is a place where there is counterflow. A smoke protection method, as I stated before, the single exit stair would serve residential only, and it would be independent of any other exiting in the building. And on top of all that, to wrap it all up, it'd be a risk analysis. All right. Now I will hand it off to the next presenter.
Thank you, Morgan.
Thanks, Morgan. Just to add, the report from GHL, I realized that went very quickly, is available online, and the link to it's been posted in the chat.
Okay, hello everyone. My name is Ian Mulder. I am an architect here at with the City of Edmonton, and we've been working with LGA on the guideline that I'll be presenting today. A couple of things here. We call this the point access block guideline. I know there's other terminology, single egress. Maybe one day we'll all come together on what the name is, but we've been calling it kind of both. We'll look at a little bit of how this came to be in Edmonton, and our particular alternative solution strategy, and how that really works for the city itself, and some of the unique qualities of the city, and some of the changes that we've made recently to zoning, especially with respect to infill and missing middle type housing. So a little background: in 2023, Councillor Michael Jans had invited Michael Eliason to come to the city, and he did a couple of public presentations, one at the university and one for maybe a bit more city staff, a bit more inside staff requirements, and of course Conrad Speckert was there as well presenting, and this really opened, I think, the eyes of both citizens and also the professionals here on the opportunities with point access block type buildings. which frankly, I don't think was on a lot of people's radar at that time. Obviously, it had been in Mr. Speckert's mind for quite a while, as it was the basis of his thesis and obviously the continuing work that has led us here today. So thank you very much, Conrad, for being such a champion of this type. But that led to a lot of opportunity that we saw here in the city, and we were all pretty pumped. Ultimately, we saw this as an opportunity to increase diversity of housing type. There was a lot of discussion on perhaps the opportunities for developers to create lower cost housing and that kind of thing. We'll see how the market responds in time, but ultimately we see this really as a question of quality housing and more diversity. So Councillor Jans put together a motion which essentially directed the administration, including my group, to start developing thoughts around this. And at the same time, of course, the CMHC Housing Supply Challenge was underway, and that enabled us to get some funding to pursue this work. And the basis of our work, of course, was an alternative solution strategy and a general guideline. And I'll speak a little bit more about what that guideline looks like and what the audience for it is. But ultimately, we've taken the approach, as has been alluded to by other folks here on the call, of essentially respecting the current code and providing the designers and owners with a basis for both understanding alternative solutions, because let's be honest, not that many builders operating, especially in the residential world, use these as a common strategy. It tends to be more common in Canada, especially for commercial buildings and that kind of thing. But on small scale residential, the hiring of specialty code consultants or fire protection engineers, to support projects is a bit rarer. So there's an educational quality to our work. And we ended up hiring Dub Architects, a well-known local firm here, who in turn hired LMDG code consultants out of Calgary to do the technical analysis. And this led to the guideline that was released in the last month. We call the Alternative Solutions Guide for Point Access Blocks. It's linked here. You're welcome to take a look at it. I believe this deck will be shared. It has 5 different subsections, sort of designed for web use. Some background information, of course. Keeping in mind that this is a guideline both for professionals, for citizens, and for the development community writ large, business people. So we've really tried to write it in a fashion that will speak to all of those folks. And for the people that need to dig deeper into the more technical components of it, the information is there, but we're not overwhelming people right off the bat. So the backbone, of course, of this work is the work that LMDG did, which is a technical report and an outlining of an alternative solution strategy, not an alternative solution itself, because we're not seeking to put in place let's call it an AHJ supported alternative solution that would work for all buildings, but essentially a guide for professionals. And the LMDG exemplar building that is described in their report asks a very important question, and that is, what would cause a single stair to fail? And of course, the analysis, which I won't get into right now, was certainly robust. You can read it in our report. They did a number of quantitative risk tree analyses, essentially demonstrating or reflecting upon how safe are current code compliant 2-stair buildings and relating those to a single stair version. And it turns out the difference statistically, quantitatively, is quite small. And so the guide is seeking to point developers and designers in the direction in which they may bring up that delta between the single stair and the 2-stair type building. The focus, of course, ends up on the stair itself, and there are different strategies that are outlined there, including, of course, pressurization of stair vestibules and that kind of thing. We have stuck to a very performance-based strategy. So this is a little bit different than what GHL, I think, has indicated today. Again, we're not seeking to hold the hand of designers or developers, but to point in the right direction for developing AHJ acceptable type solutions. This goes back to the education piece. One of the elements here that's really important to note too, because of course there's been a lot of conversation with fire, both locally and nationally and internationally on this change, let's call it, to North American thinking around single egress stair buildings, is that we've also concurrently developed a guideline for the inclusion of the fire department in the review of all alternative solutions. So this in a way took the pressure off of this particular issue, which is to say there had been a lot of focus on single stairs, but at the same time, this is possibly one issue of many that comes about regularly with respect to how alternative solutions are reviewed by the city. And so by the production of this guideline, we've been able to kind of chart a bit of a clear path for all parties, all interested parties within the city who have a responsibility for keeping people safe, both from the code perspective and from the fire protection perspective. And finally, I'm going to get a little bit into what's unique about Edmonton, or what's been going on in Edmonton. We've had a major zoning renewal effort underway for the last few years. And as of last year, we reduced the number of zones from 46 to 24 and diminished many of the exclusionary zoning practices. This is all in a bid to open up the city to new forms of development, particularly infill, and enable a lot more of that citizen-led development that Conrad spoke of at the very beginning. So part of our guide has the technical analysis, the support of the alternative solution strategy, but also this design element. And so you'll see in the guide a review of common lot types within the city and the common zones therein, and a number of massing models relative to this single egress type that are available. Again, this is pointing the development community in the direction of what they could possibly do. Because let's face it, these buildings in Canada, though the alternative solution strategy is available to anyone today and has been for a number of years, it's not a common approach. It's risky for developers to hire those consultants to do that work. And it just simply hasn't really been done very often. I think we have had, in the past 10 years, maybe 3 single egress buildings. It's just simply not part of the mindset of developers. And we want to kind of showcase here what those opportunities are within the unique characteristics of Edmonton. So then we get into some of the design elements, and again, showcasing how nice these buildings can be, the quality aspects. Really, I want to shout out to Mike Mariano and his Capitol Hill Urban Co-housing project. Quality-driven design, so often missing in the dialogue around the housing crisis and everything else that's going on in this country, but producing good quality units for people with lots of diversity therein. And that's really what we're focused on here. So I won't get into the details of some of these options, but essentially Dub has created some quite interesting designs and showing how they work within the city. So in total, there's the guideline. Happy to answer any questions, and thank you to LGA, to Conrad, and CMHC for supporting this work. So thank you.
Thanks, Ian. I'm gonna take it away here. Thanks to all the previous presenters. My name is Ryan Brewer. I'm co-founder of Half Climate Design, and I have the pleasure of presenting our studies of or our results of our study on exit stair and enclosure construction types through a life cycle assessment. Quick intro to Half. 3 years ago, we started Half to answer the question, how do we half the embodied carbon of construction in Canada this decade? And so we've been doing this by partnering with policymakers and builders to assess whole life carbon and cost on projects. So how heavy is an exit stair? The purpose of this report was to compare exit stair designs to understand how non-combustibility requirements as well as fire resistance rating could drive embodied carbon and cost through the selection of the system of the stair. So in the study, we compared 6 different designs of 2-hour fire resistance rating and 3 additional designs with a 1-hour FRR, all with equivalent frame spread ratings on the interiors for each of the designs. The baseline design was a code-compliant exit stair for a 6-story residential building based on typical industry practice of construction, and the material quantities were gathered based on this baseline. And just as a quick review of LCA, of life cycle assessment, we know all construction materials come from somewhere. So what this study does, what an LCA is the process of quantifying the environmental impacts of those materials within a building from extraction all the way through until the building is no longer standing. So these were the results. They illustrate that an exit stairs construction type significantly contributes to a building's cost and carbon. And we're going to look at the results in a few different ways as we go here. First, I wanted to just go quickly through each of the types. Very quickly, you'll see the design name, the fire resistance rating, the total embodied carbon, as well as the carbon storage through either carbonation or biogenic sequestration. Listed here. So this first design is the reinforced concrete at 36,591 kilograms of carbon dioxide equivalent, and that's the standard for measuring global warming potential of greenhouse gases within a life cycle assessment. So that's the kind of metric you'll see on each of these designs. If we go to the next design, is the precast concrete design. There's actually a 13% reduction in embodied carbon for this design. It's based on a proprietary design from a local Ontario manufacturer. It achieves a thinner wall assembly, so less material means less carbon in this case. And likewise for the concrete masonry design, which was another 11% reduction in carbon. The steel stud design, marginal difference from the CMU, a 3% increase. And here, compared to the 2-hour fire resistance rating, the 1-hour fire resistance rating for the steel stud shows a 22% reduction in embodied carbon. And that's entirely driven by the change in wall assembly from having two layers of Type X gypsum on both sides of the wall to a single layer. And you'll see this change for each of the 1-hour systems assessed. So the wood stud here, the 2-hour design, very similar to the previous, but in this case, because we're now using more wood products, there's a more significant biogenic sequestration of carbon, so nearly 1/3 of the embodied carbon. And then again, when we go to the 1-hour design, we see a dramatic reduction in embodied carbon. And then the final design is the mass timber, here showing the 2-hour fire resistance rating design. And the mass timber design was much more than the wood stud, much closer to the total carbon emissions of the CMU design. But because the volume of wood product in this system is significant, you see the carbon storage, it likewise is much more significant. And then again, for the 1-hour, you see that reduction with the reduction of gypsum used. So we're going to go on to what we learned from this, and it's really not about a choice or ranking between one or another. It's about finding an optimal solution for safety, cost, and climate for any given project and site. So a quick review of what we learned with 3 findings that I wanted to present today. The first was durability matters. Looking again, seeing the totals here shown by life cycle stage, I've highlighted in red the replacement stage emissions within each of the designs, and you'll see that some of them have considerably more proportionally than others, and those are the designs that have more gypsum board than the others. So in this set of materials, the gypsum board had a 40-year service life, and so it's in a way is a penalty on having less durable materials. This is something that, looking into the design further, we would aim to reduce. Finding 2 was balancing carbon storage. Here we see the totals again shown by element type, carbon emissions in gray on top, and carbon storage in green below. Upfront carbon is the most urgent thing we need to address. So depending on the requirements of the project, it may be more important to address the gray upfront carbon rather than adding to green carbon storage below. And then finding 3, sufficiency is cheaper. And so we combined our life cycle assessment results with a cost estimate provided by Vermeulen's, the costing consultant, and there was a pretty remarkable correlation between the two. I think the most important takeaway here is that every exit stair in a building has a significant cost and carbon implication, no matter what the construction. But even within each of these types, there are changes we can make to reduce carbon and cost. Within the concrete designs, CMU was the lowest carbon and cost option, and that feels right to us. Thinking what's the highest and best use of a material in a building? It's the question of sufficiency. What's the adequate amount of something to achieve the same results, right? So that's the goal we have, where in this case, less is less. And then this was also true for the lowest cost in carbon design, where the wood stud in both the 2-hour and the 1-hour options were the lowest. So if you were looking to half your cost in carbon of an exit stair, this would be the one to choose. And then just thinking between these 2 wood systems, it's, for certain types and heights, should we really be using the same system? So thinking about, at the different heights and different locations, whether it's in Toronto or Vancouver. And so, yeah, I think just in conclusion, this does reflect some of the work we've been doing with government agencies and with professional associations to really raise the bar on best practices for low carbon building design. We use this kind of inverted pyramid of carbon mitigation strategies often, and I think you'll see some of these designs and the choice between 2 of them really hitting on a few of these points. So for all the details, please read the report. It's on our website at halfclimatedesign.com. It's also on the Single Stair website. And thank you for your time.
Thanks, Ryan. I realized we had a number of presentations today, and so that went a bit over time in terms of scheduling. We don't have much time left for questions, but if everyone that's interested wants to stick around for a few more minutes after 1:30, we can try to get through a few of them. And in particular, I think, given that we've had a number of presentations, some of them are more directed to various presenters. So the first question is a question to Axel Mosberg specifically, and anyone else feel free to chime in as well. But in the Swedish context, and this question came from Jack Keys, how do responding firefighters deal with occupants egressing at the same time as trying to access the fire floor in the Swedish context?
Yeah, so in a Swedish context, in a multi-story apartment building, we would have a defend in place strategy. That is the general strategy in Sweden. So we would not accommodate for a counterflow in the stair or stuff like that. But for buildings above 11 floors, or 11 floors and above, we do have a firefighter lift requirement, and that would be the general access route then. But in general, the Swedish strategy is defend in place.
Then a question from Mark Showers to Carl Wallish. In the UK, Will the 18-meter height limit still be imposed if the performance-based approach B7974 is used, or is it only the two other paths, ADB and 9991, that impose this limit?
Yeah, it's a very good question. We don't know, but or in theory, if you can prove through engineering, through logic, if you go back down to the fundamentals about fire, the chemistry, the physics, how people behave, respond, etc., you probably can. But unfortunately, the guidance, the standard guidance, the two different routes, approved document B and the BS 9991, have now set out these recommendations. So in practice, I think it will be very, very difficult to prove that your design is in a way so much different from what the standard guidance recommends. And what I see in the industry already, people just have accepted now that we have a height restriction. So yeah, I don't think people will use performance-based design. Unfortunately, I say this with a heavy heart because it's obviously, yeah, often the right thing to do.
Then a question from Brad Anderson about standpipes, and perhaps this can go to GHL. Standpipe requirements have not really been mentioned. Have you run into issues with only having one standpipe in one exit?
Haven't run into any issues with that. We would just suggest that follow what the building code says for standpipes, provide it when as required, and give the correct clearance around it.
Then another question actually from Brad to the Seattle context. Is there a restriction on occupancies in the exit, and particularly, I guess, referring to the balconies and community spaces, so that sort of exterior passageway condition? What sort of constraints did you face in the design of the exterior passageway?
I mean, slightly wider than the minimum required. We haven't had issues. I mean, there is a lot of stuff out there, but we make an effort to keep the space clear. Nothing else really came up specifically. It's an open balcony, so it was presumed that smoke would not gather at the underside and indeed access to the stairwell.
And then this is a question was submitted during the Sweden presentation, so to Axel. Have there been any recent fires in the higher SES buildings to confirm theory with practical evacuation of occupants in the event of an emergency?
We have there are fires all the time, and that's similarly to Carl. We have quite a large amount of single exit stair buildings, so there is fires every now and then, unfortunately. But if we look at the statistics, we do not see a significant, a few years back at least, when I looked last time, we do not see a big difference between taller buildings and low-rise buildings. We, similarly to the statistics you show, have a vastly higher death rate in single houses, and then apartment buildings are much safer, but the height difference does not affect the risk, at least statistically, not that much.
Another question from Hamid here about, and maybe if anyone could weigh in on this one, between the number of units per floor and number of dwelling units per floor and the height of the building, which is more important to restrict for a single stair? I mean, challenging question, but if you wanted to comment on the relationship perhaps between number of units and occupant load and building height and floor area and travel distance.
I'm happy to say something from the UK's point of view. It's probably the height rather than the number of units, because we restrict the length or the dimension horizontally of this single stair building anyway. because we have travel distance restrictions on the dead end. So I think we will never be able, because we need to achieve certain square meters or feet for people to live in. And I don't think that we'll have a high number of flats on one level and all wanting to a single stair. It's probably more the height, in my view.
So just to give another perspective, then I would say, I would say that the big difference between a single stairs solution in Sweden and a multi-stair solution in Sweden would be the number of flats per floor. So generally, if you have 2 stairs, you would have more than double the number of apartments in that building, because then you have a much higher allowance for the travel distances. If you go in one way in a corridor, you're only allowed to go 10 meters, but if you can go in 2 ways, you can have a 60-meter corridor. So when we look at doing our performance-based design with single exit stair solutions, it's quite easy if we have a reference building or a reference safety level with a 2-stair solution to say that at least if you're looking at a single floor, the single exit stair solution is probably going to be safer, because if you smoke fill the corridor, you would still not be able to exit, even if you have 2 stairs, at least in this, if you do a Swedish safety design. So in my view, that would be the number of apartments would affect the safety level more. But if you just compare a single stair to a single stair, I guess I would agree with Carl that the height is more important. But when comparing the different solutions, I would say the number of apartments is important.
Then another question from Laura here on buildings with additional mechanical systems will be more expensive. The question then relates that to water supply, but maybe I can simplify it a bit. To the various groups that have requirements for smoke control measures, be it mechanical or passive, if anyone wants to comment or talk a bit about the cost and design and complexity of smoke control systems.
I mean, at least in our experience with our project and the one I shared today, and passive open ventilation of the balconies minimizes mechanical systems. We've got the stair pressurization fan. We've got a passive damper at the top of the elevator, and those need to be tested on an annual basis, but the equipment wasn't really that significant, and certainly a lot less than the cost that we pay for elevator maintenance contracts. As far as the volume of water for the additional sprinkler system throughout the building, I don't know.
I know we're just about over time, so maybe I'll just a chance if everybody wants to say put a brief 1-sentence, 2-sentence summary of their perspective on single stair, their perspective on their own presentation. If there's one takeaway you'd like the people attending to bring away the session. We'll start with Axel. No pressure.
That's a tough one, but I think I mean I'm of course colored by the Swedish legislation and the Swedish fire statistics, and my point of view is a Swedish one. And from my perspective, the single exit stair solutions that I've designed and are involved with, I regard them as very safe buildings. And I think that the stair is of course a very important element, but I think my son just jumped in. I think there's are others elements that might be more important.
Yeah, my view is that obviously I have worked for many years in a country where single stair residential buildings were possible to any height. And I've seen, if you design them right, holistically, robust, with all kind of different measurements, I do believe they can be safe. And seeing now in the UK that we have this height restriction, and they drop down, in my view, really low to 18 meters, and seeing what you are trying to achieve to raise the height. And actually, we are all about 6 stories, 18 meters. That's very similar. I think, yeah, I wish you luck. because I think you're on the right path. And I really believe that you can come up with solutions to design them safely. We've seen great presentations, great solutions, and I'm not worried about the height and the things that you have in mind. And yeah, I wish you all the best. Thank you.
Then we'll go to Mike.
I mean, at least with the project I shared, and we didn't set out to do anything groundbreaking. It was just, using the single stair exception in the code to make an efficient building. So for an urban infill solution, at that scale, it worked really well for us. So, I'd love to see more projects at that scale and encourage you all to do the same.
Morgan.
Yeah, I think for us now, this is kind of where the rubber meets the road. We are now we're going into writing alternative solutions based on this now. So we're hoping that it moves forward and we can get some positive change here, unlock some more building typologies, and yeah.
I think that's Ian next.
Yeah, diversity of type and being aware, as my presentation alluded to, of what are the interests of the marketplace, because fundamentally it's those folks who are building and, helping to support them, and bring that, the knowledge from these kind of discussions, through our professional associations and relationships with builders and others. I think it's really important to make it as normal as it is in places like Sweden to have these kind of buildings. That's kind of the remarkable thing to me, is that, we're in many ways we're twisting ourselves in pretzels, and yet here they are living pretty meaningful and normal and safe lives over there. Obviously with differences in culture and firefighting and materials, but nevertheless, anyway, hopefully in 10 years we'll be talking about this like it was old news.
And then we'll end with Ryan.
Yeah, I think the goal is to build high quality housing, building houses, not corridors and basements and parking. It's about building housing that's good for people. And this, based on the work like the professionals here and others, seems like this is a clear pathway to get, optimizing for cost and carbon and safety. So, yeah.
Well, I realize it's been a long session, and compared to yesterday, which it's easy for architects to talk about architecture, getting a room full of fire engineers and architects to captivate an audience for an hour and a half is a challenge in and of itself. But hope that the attendees enjoyed the presentations, and maybe I'll turn it over to Jennifer to just do another plug for what's happening tomorrow.
Yeah, absolutely. Thank you, everyone. And thanks to those of you who are still with us. Just encouraging you to sign up for the third session as part of the series, which is our City Talk tomorrow at noon. You register through a separate link, which I believe has been posted in the chat, and we look forward to seeing you all there tomorrow. Tomorrow's conversation will be a higher level discussion with a variety of experts to talk really about how design innovation and regulations can help to, in fact, enforce and see greater housing diversity in our communities. And thank you very much.